the main items of Z notation is the set. Actually, okay, before that, okay, the schema, but we come to the second one is the set. Everything we have to use set in everything. Guys, you see, guys, I want to compare now between these two examples. We have the first example, it was the counter, and the second one is the birthday. So here we don't use, in this counter we don't use any set. Here we use set, because if you see, is the difference between the totally different, these two examples. There we have only one items, and there is, you don't have to add anything, just this item, it's change. You just change this value. Counter, we just change increase one, decrease one, like this. But here we have to add some information for each to save people information. So if you see the different type. So later when you have the example, you just first, okay, think about it. Do we need set or we do want? So okay, the items, okay, maybe one items is the types. So you know how to define the types. So we have some basic types, or we can say predefined types, something like Z note, Z. We have the Z is the negative and the positive. We have the integer. Integer is only negative, or the integer number. N, that's mean integer. I mean, we have also, you can create your own set. You have create your own set. This is red, yellow, green. This is set of color. You can create your own set. So here is the integer, here the natural number, that's mean without, or no, starting with 0. If we write here is the integer. This one starting from 0. This is starting from 1. R is the real number. So here also we can define, similar to what we do in the remind example, we can define our system or our one set like this. So this one, just the definition, is more explanation what's mean this. If you see here, n we see is the integer, but without, you see now they use the difference, without z, without 0. And this one, it's the integer but is greater than 1. I mean, now the difference between these two types, not two types, these types. Okay, this is the existing types. As we say, we can also define our own types. So here you see, here is all the set. We have, you can define any set, and this one is the null set. Okay guys, as we say, we have now, after we declare the state, so each items in this state we can say is the object of this schema. Okay, the variables is the objects, and then how to declare this item, we just we declare it, as you know. Okay, this is should be earlier, but okay, I want you to know the structure, and then I come. That's why you see in the outline I start with example. I just, when we start, I change that to the example, to the first, because I wanted to know why this one. We just, because every year I start with this. So students don't know why we take these things, but now maybe you know why set, why we need to define the, I mean, why we need to know the operation on the set and the types and another things. So I start with example. Now maybe you know the example, and then anything, oh, okay, this is because I will use it for adding items. This I will use it for deleting items. This I use it for declare the variables, something like this. So here, how to declare, just, before already, okay, you have the item, okay, the variable, and then just name of these data types. Okay, so if I write x, it's belong to z, that means x is one variable of this set, which is integer number. So, but if I write x belong to, this is also more details about it later, belong to bz. So here x is one variable, but x here set of x is set of item from the integer number. So this is the what we mean by this b. So b is the power of. So if you want to declare one item, so without this b, you see is this one is bold. We have this in the our Z notation. If you want to declare is one a variable, so you just declare it without mentioning this. If you have many, so you just add this before the data types z. So here we have another one example. If we say we have the book is the big set is the set book. Okay, so if we say we have some unknown set and we have some reference, or we have unknown book and we have a reference book, so the something like now both of them it's subset of this book. So how we declare it? We just use the name and then b and then box. So now we can say, and then also the reference and book. So we can say is unknown also, and the reference is member of book. Also both of them is set. Both of them is set, not item. Unknown is member of book. So this is the power set. What mean power set? So if we have now here the power set A, B, C, so this is the subset of this power set. Okay. So this is now we already use this one, and you know how and where we have to use it. You see now, this is the idea. Now you know why. This is the comprehension set. So we already use it in remind operation. So in remind operation, actually, we have, as we say, not only one item, the output, we have many items. So is we have set. So you know before you just set, we can say, okay, the set is red, green, yellow. So we have, for example, this you can define this set. But okay, your set is not just okay number like this or item like this. It's maybe it's you can have to derive this set from another set. So we can use now this type of set, or this is just expression for, or we can say description for your set. Another way to describe your set. Okay, this is another way to describe the set. So we have set comprehension. We use it many times. And you have to learn how to, you can say, represent your set using this comprehension set. So we can say in general we have three items or three parts. You see this part, and this is the second part, and this is the third part. Okay, the first part is the declaration. We say here is D, declaration. The second part is the predict, is the condition. And the third part is the expression. So not all it's necessary. Some of them maybe can, we can represent our set without one of them, for example, without the expression, without the constraint is okay. But it's, I think the declaration is necessary. So if you see here this example, now we say what? We have x, it's set, or we can is the number. Set is a number. This set is belong, or this x belong to the natural number. It's any number from the natural number. Any number from natural number. But the condition, we say, but this x is less than 5. So the natural number is 0, 1, 2, 3, 4, 5, 6, 7 until maybe 32,000 something. This is the natural number. So here we have a condition that's only until 5. Only until 5. That means the item only until here. So this is the x. So what else? What else? We have expression. Expression here we say now how to generate. This is now we find, okay, the item of this set. So now how to generate the item of the new set. generated based on this expression. That means x it's square, it's square. So what we have to find now? Okay, the square of x of 0, 1, 0, and then 1, 4, 9, 16. Okay, not without 5, 16. Why? Because here it's less than 5. That means here the item, and then now we use the expression to generate this item. I think it's clear, guys, right? So first we have to the declaration where this item is derived, and then the constraint, some constraint, as we say here, is less than 5. So we don't go for more than 5. And the third one is the expression. So this is the way to generate. I will generate based on this expression. I will generate the item based on this expression. So we have declaration, predict, which is the constraint, and then the expression. Is the same here, same things. We have x is maybe it's more general or more clear than this. X is belong to t, and then this is the predict of x. That means the constraint. After that, the expression of this x. Maybe if you read this one, you will get this set of all elements that result from evaluating this expression for all x of type t. The x is belong to t, for which the condition for which this predict is true. Okay, guys, this is another way to represent or to express your set, because not every times we have the clear set, the number, the elements. Sometimes we have to use this kind of representation. So here another example. If you see here what this, you see here not all the parts is there available. So for example here we don't have, in this example we have only predict and the not predict, the declaration and predict. We don't have the expression. That's mean okay, all the item x is belong to z, all the z numbers, and then x is greater than 0 or equal. So this is the natural number. You know this is the natural. Then empty set x it's belong to t. So t should be, you should see what's the t, and then it's false. So this item is empty because it's false. All is not many. I mean it's always false. That's mean not satisfied. Always not satisfied. So it's always. Or we can also the same thing here using different types. So guys, this is now example for you. So we have here x is type of n, natural number, and x it's multiply x. So if you see here there is no predict, so it will be infinity numbers. So what the numbers here, what the value of this set, what the element of this set. Okay, what the element, guys? Hello.
X is a natural number.
Okay. Oh, sorry. So I mean the elements. What the element?
So
X is the natural number. The natural number does mean what? 1. Okay, natural number starting from 0. Yes, starting from 0. 0, 1, 2, 3, 4. And then we have now the value to generate this. We should use this expression. That means we just multiply each number in itself. 0, 1, 4, 9. So it's the same our example, but here without any constraint, just for all the numbers. So here we have, is it with 0? There's a natural number. Natural number should be with 0, right? With 0, yes, with 0. Why we start with 1? with 0, guys, here. Okay, okay, I will fix it. No, I will not fix it now. If I fix it, I will check these things. Okay, no, later I will fix it. So guys, this is another example. Okay, this is, maybe we don't want to start because we already maybe around 9:30. Guys, sometimes also we have not only one items. If you see here this example, each item is only one variables, one item. So sometimes the items of the set is bare. Okay, bare, that's mean not only one item. So you see here we have each element is bare. So this is the difference here between these two examples. Just each element is bare of x and y, x and y, x and y. So the others is same. The others is same. So here we have x is member of this set and y is member of this set. So without any constraint, without any predict, just all the elements. No, this is the constraint without any expression. So here we will have set of elements and each element is bare. That means we'll have one with 4 and one with 5, 2 with 4 and 2 with 5 and something, and all like this. Okay, one with 4, one with 5, all the items, all the possibilities. So here we add the expression. Just we say x plus 2 equal to y. Okay, so this one the same thing. Just okay, if you see here the elements, all the elements, you can first list all the elements and then you just verify this expression. So only the elements that if we have x, this is x plus 2 equal to y. X, for example, here x2 plus 2, 2 plus 2 equal to y. 3 plus 2 equal to 5. So only we have the constraint. So guys, this is another way to express your set. You have to learn also how to do that. So the operation on set, okay, the operation here is the same thing. We say how we add, how we delete. So this is the operation, how to find the number of the elements. So the first one is the size. The size, which is the number of. So if you see here, just use hash to return the number. We have here how many elements? Okay, we have here red will not be counted, will count only one time. So we have, so here if we want to add, you see here, if you have two things you want to add together, you can add it by this. And see the difference. The difference is to delete. We want to delete this item. We have this set. We want to delete these items from this set. So just add this item or delete this item. So here the operation on set. Okay, the last one is the intersection. That's mean only the elements that belong to two or is common in two set. So this is some errors here. Okay, cannot different types of set cannot combine together. This is more about this. Somebody text me. Guys, we are in the class. How you text me now? Okay, later. Okay, guys, this is okay. Here the set, all the operation, all the set, all the operation. Now it's more detailed, so maybe we can just this is more details how to combine. This is using union. This is intersection. This is the complements. You know the complements is the other elements, of set, the other elements of A. Okay, you know the complements. So this is the difference. You know the difference, and we have to use it many times. This is the difference to delete item from set. This is universal set. Universal, it's Okay, is the we can say is the general elements. If you have, for example, A and B, so the universal set is the combination of these two elements. This is actually, you don't need to repeat again. This is here some examples of this universal. So guys, the relationship between the set, the relationship between the subset. This is where we use this relationship. Actually, we use it mostly in condition. If you have any condition, I think we have used these things. For example, for the precondition, we use this kind of relationship. And the output of this is true or false. Okay. The second place also, if you see in the comprehension, we use it also in the predict parts. So also we can say this set or the set that we are going to generate is member of or related to this or belong to this set or subset of the other set. So here we have the membership. We say okay, X is membership if X is have some elements in element of S. Okay, here this is not membership. Okay, this is subset. If X is if subset of S is a subset of this. Okay guys, one thing's also here, if you see here, we say about subset, or we can say not subset, is the membership. That's mean we have one item and it's membership of this another item. That's why we say when you, for example, want to check the name, you say the name it's member of known. You remember this, right? So if you see here is one variable only, and here is set. But in this, which is subset, is belong to two set, is relation between two set. Okay, I don't think is that difficult. You have later when you compare two set, use this subset. When you compare item with set, use this membership set. This is its proper subset of T and is not equal. Okay, it's clear, is not equal. Okay, just member of or element is a subset of S, subset of the T, but it's not exactly equal to this element or this subset, this set. So here how to use it, and we say is the output is always true or false. That's why we have to use it in the predicts, in the condition. We have also is the proper subset, this one. This is just some examples, more example about it. This is, so here arithmetic operations, and this operation is actually is similar what you have learned in another language. Is the additional, subtraction, multiplication is the same what we have learned before. Only a few things is the difference is the last two, which is related to the set. Just maybe we have these two. Even this one is also the same, but this two is max A. If you have array, not array, set. If you have a set, this set is A, for example. So you want the maximum number in this array, in this set. You have the maximum number of this set, so you can use just max A or minimum A. So here, back to birthday. I already explained how, right? So now if you want to delete, we just use the difference. We have the birthday or the noun, right? The birthday relation, and then difference, the one you want to delete. For the total number also we can use for the noun, or we just use hash, for example, hash the noun or hash the date, because the same, or hash the birthday. So for adding the place, also I explain you can use two option. We have two options. We can add something, the relation, the noun is we can say it's the noun or the name. The name is related to the birthday, right, and related to the place. Or we have two relation. We can have two relation, n related to the birthday and also n or the name related to the place. So you have to write this or this.